signed number, there are three methods. One is a signed magnitude, another is r minus 1's complement, radix minus 1's complement, and another is 2 complement or r's complement. So this is the number here. Okay, so this relation you will follow. So that is n is the number. For example, here is a one number. You have to get 9's complement of a decimal number. 3 decimal number, no base, no need to represent the base. If base is given, you can consider that base. Now here all the integer values are there. So there are 4 digits. So and the value of n is 4. There is no fractional part. Decimal, after decimal there is no value. So the value of m is 0. The value of m is 0. So number of digits in integer part is 4. Number of digits in the fractional part m is 0. R minus 1 is n because the base r is 10. We are having a decimal number. For the decimal number, the base is 10. This is important. Now, 9's complement of 3, 4, 7, 5 is equivalent to 10 to power 4 to the base, which is having a base decimal, minus 10 to power minus 0, 10 or minus the number. So, if this is represented by 4 place value, here is 10 to power 0, 10 to power 1, 10 to power 2, 10 to power 3, 10 to power 4. So 10 to power 4 is 1, rest all are having a 0 and minus 1. And if you go far, you will find a 999 minus this number. So 9 minus 5, 4, 9 minus 7, 2, 9 minus 4, 5, and 9 minus 3 is 6. In case no base is mentioned, it means in case no base is mentioned, it means number is decimal and base is 10. Number is decimal and base is 10. So that is a very important one. So here another method is directly you can say subtract each digit of the number from the largest digit of the base. Largest distinct digit of the base. Here is a decimal number. Largest digit is 9. So you have to subtract each digit from 9. So you can follow this operation. So directly you can go. Or no need of all these operations. So you can skip all these. Only you can say, you can just subtract each digit from the largest digit of that number, that base number. Here is a decimal number, largest digit is 9. So 9 minus 5, 9 minus 7, 9 minus 4, 9 minus 3. Directly you can get. Later on I will come to that point also. So here is a fine number where decimal number is, integer value is also there and the fraction number is there. So the value of n is 3, value of m is 2. What is 2? After the decimal there are 2 digits. So the value of m is 2. Before the digit the number is 3. So digits are 3. So integer part is having a 3 value. Base is 10. Base is r is 10. R minus, now here 9's complement you are taking. If you are talking about the 9's complement, so it will be 9 plus 1, base is 10. Already decimal is given, that is also representing your base. No base is given, again it is representing, there is a base. So I can represent here 10 to power 3 minus 10 to power minus 2 or 783.45. That is the number. So 10 to power 3 is represented by 100. So 10 to power 0, 1 value, 10 place value, 100 value and 1000. 10 to power 3, rest will be 0. Here is 10 to power 0. 10 to power minus 1, 10 to power minus 2. So 10 to power minus 1 is having 0 value, minus 2 is having 1 value. Subtract it, you will get 9. So that is again coming out to be the same. You have to subtract largest digit of the number from the each digit. 9 minus 5, 4. 9 minus 4, 5. 9 minus 3, 6. 9 minus 8, 1. 9 minus 7. Directly you can write. Or if the procedure is asked, then the procedure is this one. So now here is r minus 1's complement of a base r number is obtained by subtracting each digit from the base r number from r minus 1. R minus 1, or you can say the largest digit from the set of base r distinct digits. So always remember largest digit from the set of base r distinct digits. So you consider, for example, 9 is given, 9's complement is given, you are considering a base 10. So what is the largest digit of that set of base 10 decimal number? That is 9. So you have to subtract 9 minus 7, 9 minus 8, 9 minus 3, 9 minus 4, 9 minus 5, you will get 216.5. So that is 9's complement of n. Okay, so that is there. So here is 2's complement of base 3. 2's complement of base 3. Base 3, largest digit of base 3, that is 2. So you have to subtract 2 minus 1. 2 minus 1. Okay, 2 minus 0. 2 minus 0. 2 minus 2. 2 minus 2. 2 minus 2. 2 minus 1. But don't change the place. Don't change the place. Be careful. So this decimal will remain at the same place. Similarly, here the base 3, base 4. What is the largest number? 3. So 3 minus 1, 2. 3 minus 2, 1. 3 minus 3, 0. 3 minus 0, 3. Decimal as such. 3 minus 0, 3. 3 minus 2, 1. And 3 minus 3, 0. So similarly here 4. So similarly you can get you have to subtract the largest digit number. So find radix minus 1 complement of the given base number, that is 37257. Now here what is the procedure I want to discuss here? Because radix minus 1, it means 6 complement. Base is 7. So number of digits, integer values before the decimal point 0. So your relation is 7 power 4 minus 7 power minus 0. Be careful, don't forget to write the value 7 here. So 7 power 4. So this is the 7 0, 7 1, 7 2, 7 power 3 or 7 power 4. So 7 power 4 is represented by 1, 2, 3, 0, 1, 2, 3, 4. 7 power 4, rest are 0 minus 1. When you are subtracting 1, so it means your base value. 0 is less than 1. So you are going here, for example, here is 1, 0, 0, and one more 0 is there. You are going to subtract here, equalize. There is need of the borrow. So you will get a base value 7. 7 minus 1, you will get 6. Again minus 1. Here is 7. You will get 7 minus 1, 6. Here is minus 1. Base value will be 7. 7 minus 1, 6. Minus 1 and 1, 0. So this is your 6 in base 7. Now again 6 minus 5, 6 minus 2, 6 minus 4, 6 minus 3. Or you can say subtract the largest digit from each digit from the largest digit of the set of distinct digits of 7 base. 7 base distinct digits vary from 0, 1, 2, 3, 4, 5, 6, 7, 6 only. So largest distinct digit in base 7 is 6. So you have to subtract 6 here. So this is the same here. 5. 5 is there. 5 power 3, 5 power 2, and base that can be represented in the base. You can subtract, you will find this one, and ultimately you will get the result. So another is the trues complement, widely used in the computing system. That is a true complement. For example, here in this, you are having a 00 value in the decimal number. What will be your ninth complement? Ninth complement means you have to subtract largest digit. 9. 9 minus 0, 9. 9 minus 0, 9. 9 minus 9. 9 minus 0, 9. So if 0, you have to subtract, its complement must be equivalent to 0. If it is not coming out to be 0, then there is a problem. Then you have to make it as 0. Okay, so radix minus 1 will not give you the complement of 0 as 0. So this is a disadvantage, and we never prefer in the distal systems. Your computer is not following complement, one's complement or radix minus 1 complement operation. It follows the two's complement number. For the two's complement number, if your number is 0, the complement value is 0. This is the advantage. And here is r power n minus n, if it is not equivalent to 0. Okay, n is a positive number, r, n is the number of digits in the integer part. Fractional part we never touch, but we have to consider, but we are not touching it. So here is tens complement of the decimal number 3475. How many digits? Before the decimal point, we consider decimal point here. No, nothing is there. We can consider 0. So no digit is there. So here 4. 4 is there. So it is 10 to power 4 minus 3475 because the number is not equivalent to 0. So then we can say here is 1000 minus 345. Now, can I write it as 999 plus 1? This is equivalent to, or you can combine. So this value is giving you 9's complement, and add 1 to it, you will get 10's complement. So 2's complement you can obtain by taking radix minus 1 complement and add 1 to the least significant digit. Only one value. Okay, so this is the value you can get. Here is a decimal point. So again 10 to power 3 minus so on. Equate the digits so that number is not affected. So this can be written in this way. So this is 9's complement, and here is, note it, because you are taking a 9's complement and add 1 to the least significant digit. Least significant digit is 5. So you are going to add 1 to the 4. Here 4. So here is the last significant digit. So this is 21655. So here is 4 only. 10 to power 0 minus this one 1 can be written as. So you can segregate, rearrange. So this is you are adding here 1. So if, for example, you are getting this number 654, general mistake is given so that I subtract 1 here. That is wrong. Okay, so then what you have to do? You have to do that this value, if here you are having a number 76454, you have to add 1 here. So 1 means it is an integer value 1, but all the digits are same. Now you can add, here will be 5, 6, 7 and 0. So this is the value 4 plus 1. Okay, so here r's complement of base r number is obtained by adding 1 to the least significant digit to its r minus 1's complement. To r minus 1's complement. That is important. First you take r minus 1, the radix minus 1's complement, and add 1 to least significant digit. Why I am stressing on least significant digits? For the integers, it will not affect, but when you are considering a fractional part, then there is a problem. But when you follow the computing system, a register always represents your integer value. So these are the numbers, and the various examples are there. So no problem. So here is, so this is the find the So I want to discuss this example. So 10th complement of 4. 4605 is the number. 9th complement of this number is, what is the decimal number? What is the largest digit? Is 9. 9 minus 9, 0. 9 minus 0, that is 9. 9 minus 6 is 3. 9 minus 4 is 5. So that is given. Okay. So then you add 1 to the least significant digit. So here is 5391. So here is. So now here you have to take the complement. Complement means 9 minus 9, 0, 9 minus 4, 5, 9 minus 0, 9, decimal as such, 9 minus 6, 3, 9 minus 0, 9, 9 minus 5, 4, 9 minus 1, 8. So this value is there. Now you have to add 1 to the least significant digits. Now by subtracting you are getting 0. Don't ignore this 0. So this 0 you have to consider, because here is a 3-bit number, 3 digits, here 3 digits should remain as such. Now here 0 is acting as your least significant digit, and here some mistakes you will do generally 493.95, and this 0 is ignored, so you will add here, that will be wrong result. Okay, so be careful. So here is 4302, 5, base 5. What is the largest digit in base 5? 4. 4 minus 4, 4 minus 3, 4 minus 0, 4 minus 2. Here is the integer number, so you subtract 000, add 0001, least significant digit. Here is, you have to base 7, largest digit 6. Subtract 6 from each digit. 6, subtract digit from largest digit of base 7, that is 6, and then now here you have to take care that you are going to add 1 to the least significant digit 4. So this you have any doubt, you can ask this one. This is very important, because this is the base of your all the operations. If you have any doubt up to now, any doubt you can ask, then I will continue from the next. Hello. Used to perform subtraction and to represent signed numbers. Complements are used to perform subtraction and to represent sign. Sign means you are having a positive or negative. No need to write the message, because I'm not going to set it. Positive numbers are known as unsigned numbers. Positive numbers are known as unsigned numbers. Be careful. All positive numbers, 0 to 10, 100, 1000, 2000, 10,000, whatever it is. Signed numbers can be positive or negative. Signed number can be positive or negative if it is a combination. Subtraction is done by doing addition. What is the advantage of the complement? Complement numbers are used to represent the signed numbers, and subtraction is performed by doing addition using complement. This is the advantage of the subtraction using the complement. Then what to do? First, you have to take the r minus 1. If your m minus n, you have to consider. M is your minuend, n is your subtrahend. Both are positive numbers. Negative sign you have to consider. Okay. Any carry is your n plus 1th digit. If you are performing n digit numbers, n plus 1th digit is considered as a n carry. So if you are having a 2 power n, the last digit case value, your carry will have 2 power n plus 1. So that is there. N plus 1th digit is considered as a n carry. This point you have to note. So because we have to decide the operation, 4-digit operation, 5-digit, 8-digit, 16-digit, 32 digits. So first you have to take the r minus 1 9's complement or r minus 1's complement, radix minus 1's complement of the subtrahend. So how you can get? Subtract each digit from r minus 1 value. R minus 1 is the base value. Add manuend m to the r minus 1's complement of the subtrahend. Now perform the addition of these two. Then you have to check the carry, end carry. If an end carry occurs, add 1 to the least significant digit of the number obtained after step 2 and place a positive sign. It is a positive number. If an end carry doesn't occur, if end carry is 0, then you take r minus 1 complement of that number and place a negative sign. So there are two. First, you have to take the r radix minus 1 complement of your subtrahend. Add that complement of subtrahend to the manuend. Then you check the end carry. If end carry is 1, add to the least significant bit and place a positive sign. If it is 0, then take r minus 1's complement of the number and place a negative sign. So this procedure is simple. So here is if r minus 1 is there, base is 3. So now here you can get what is the value of m? That is m is 1010, n is 1011. So you have to take 2's complement of 1011. 1011. How you will get 2's complement of this largest digit? R minus 1 value. 3 minus 1 is 2 value. R minus 1, you simply remember R minus 1 value. If R is the base, R minus 1 value is 2. 2 minus 1, 1. 2 minus 0, 2. 2 minus 1, 1. 2 minus 1, 1. So this is the 2's complement of subtrahend. The value of m is given. 2's complement value is given. Add them. 0, 1. 1, 1, 2. 0 plus 2, 2. Because 2 is a valid number of base 3. Valid distinct digit of base 2, base 3. 1 plus 1, 2. So here is 0. Here is 0 value. So then end carry is 0. End carry digit in because we have decided 4-bit operations. So what is available in 5th digit after the operation? So that is considered as carry, end carry. So end carry is 0. So then what you have to do again, take 2's complement of the number. Take 2's complement of the number. So what is 2 minus 2, 0. 2 minus 2, 0. 2 minus 2, 0. 2 minus 1, 1 and place a negative sign. So this is your answer. Again I am repeating, take r radix minus 1 or r minus 1 complement of the subtrahend. How you will get? Subtract each digit from r minus 1 value. Okay, then add. Then you check the end carry. If end carry is 0, take again the same complement by subtracting the r minus 1 value. Your base will not change throughout. So number of digits of manuend m and n must be same. Otherwise you will do the mistake. So that is there. Now you take the example here. So here is 3 digits, here is 2 digits. That is, you have to make this 2 digits to the 3 by placing 0. So the number will not affect. So must equalize your number of digits. Then you take 4's complement. Radix minus 1. R value is 5. So you have to subtract 4 minus 4. 4 minus 3. 4 minus 4. So 4's complement of n, that is 0, 1, 0 is 4, 3, 4. And then you can add 0 plus 4. 4 is a valid number of base 5. 1 plus 3, 4. 1 plus 4, 5. 5 is not a valid number. Or you can say 5 is more than 4. So that you have to subtract 5. then here is 0, here is AND carry is 1. If AND carry is 1, you have to add into the least significant digit and place a positive sign. So then it will be equivalent to 0, 0, 0, 1 here. So 1, 0, 0 is your result. So similarly here you have to equate it. In this part, decimal parts are not there. Here, integer part is 0. Here, 3 digits are there, so you have to equate it. Be careful. Now you perform the operation. Same. Your base is 7, so you have to subtract 6 from the each digit. 6 minus 0, 6 minus 0, 6 minus 0. Because these 6 are participating. If you ignore it, so you will consider here 0, your result will be wrong. So this is your value. So this is R's complement. Here again you will take 2's complement of the subtrahend, add with the manuand, then you check the carry. If AND carry is 1, discard it. Discard it and place the positive sign. So here place, if it is 0, so naturally you have to take the negative number. Negative number is always represented in 2's complement. Okay, 2's complement is preferable, so R's complement subtraction method to follow. So here is your N is 1, 0, 1, 1, base is 4. So 3 minus 2, 3 minus 0, 3 minus 1, 3 minus 1. Okay, so this is your number. 4's complement, add 1 to the least significant digit. So it will be a 4's complement. Now add them. 0 plus 3 is 3, 3. Here is 0. So you have to take a 2's complement, or you can say here radix minus 1, 3's complement, 4's complement, and place a negative sign. It is what we say generally, subtract 4 minus 3 and rest 3 minus 3. So this is the basic anyhow. So again you have to equate and you have to perform. You will get the same result. Here is 0, 1, 1. You have to discard and place a positive sign. So this is the difference only. So you can do here. Next time we will discuss what is a binary system, which is very useful. But only all the previous we will follow.